Okay, so the idea is to talk about a critical section in the code and understand what we need in order to solve this critical section. So the idea of critical section is a section in the code in which multiple processes uh, can access, but if multiple processes access the critical section code segment at the same time, there might be racing problem, might be problems. Um, and why? Um, this is because um, when two processes get into the critical section, what there is in the critical section is things like getting access to shared data, shared resource, changing shared data, shared resource, and then when two processes do at the same time changing uh, the same resource, there may be problems with synchronization and weird things can happen. So we need to make sure that only one process at a time get into this critical section of code and no other process gets into this section when one process run this area, run this code segment. So how can we do that? We can lock the critical section. When a process gets inside, we lock the critical section and no other process can get inside. The other processes can wait in the waiting queue, but no one gets inside. We can do it, for example, using mutex, which is like a lock. When a process is inside, he locks the critical section. When he ends, he unlock it and other process can get in. Now, the idea that we need to lock the critical section and only one process at a time can be in the critical section, this is called mutual exclusion. Only one process can be in the critical section, execute it, while the other can't at the same time. How do we do that? Like using mutex and blocks and things like this. Now, the other thing that we need that in order to not get stuck, the processes are waiting to get inside the critical section in the waiting queue. Now we need progress, meaning that if a process finished the critical section and now the critical section is free, we must be able to choose from the waiting processes a process that will be able to get inside the critical section and not let them be in the waiting queue indefinitely waiting and no one is chose. So progress means that if the critical section is free, someone from the waiting queue must be chosen and not wait indefinitely. Now, bounded waiting means that when we have some processes waiting from the critical section, it must be that every process eventually will get into the critical section and not wait indefinitely. Namely, we want to prevent starvation of a process. We need to make sure that not one process stuck here and every other process come and get by or something like this, but every process eventually will get into critical section and not starve in the waiting queue. Now let's see how it goes. So we get the processes in the waiting queue, and then one process at a time get into the critical section and locks himself until he finishes. When he finishes, the critical section becomes free, and we need to choose based on the progress another process that gets into the critical section. Now, every process eventually gets into the critical section because there is a bounded waiting. You won't wait in the waiting queue forever. So you see that critical section, one process gets inside, locks himself, no other process get inside until he finishes. When he finishes, another process is chosen to get inside the critical section. And this is the idea of critical section problem, the problem that we don't want some processes simultaneously running and executing the critical section. And the other thing that we need in order to solve the critical section problem such that it won't run indefinitely and no process will starve. So we need to solve the critical section. Mutual exclusion, which is a primary role. We need progress such that no process will wait and no to be chosen, and we need bounded waiting. Eventually, every process needs to be chosen. Mutual exclusion, progress, and bounded waiting are the rules that we need in order to solve the critical section problem. And that's it. Thank you very much.